Okay, good afternoon. So we start a new lesson here. So that is a simple but very important lesson, algebraic identities. So I already talked about what an identity in algebra is, yes. So if you have equality which between algebraic expressions that is satisfied for all possible values of the variables, then that is called an identity. Of course, I don't know. For example, if I just write a plus 3b, and then I multiply it by, for example, 2a plus 5b, and then minus 6ab. For example, I can write it like this. Then I can, for example, I can expand this. It becomes 2a squared plus 5ab plus this one is 6ba, and then plus 15b squared. And then, of course, at the end I have minus 6ab. Then I can simplify it. It becomes 2a squared. Then this becomes 11ab minus 6ab is actually 5ab. And then I have 15b squared. So, for example, if I write something like this, this is an algebraic identity. Minus 6ab, I can write it, this one is equal to this expression. Yes, so this is an algebraic identity. What do I mean by that? I mean that if you replace any arbitrary pair of numbers for a and b and calculate the left hand side and calculate the right hand side, the answers will match. Yes? So this is an algebraic identity, but this is not one of those algebraic identities that we want to learn and, I would say, memorize. It's an algebraic identity, it is a formula, but it is not something that we actually need to remember it. But there are other identities that are useful to remember and work with them. The reason is that in most cases when you are doing algebra, they will actually pop out. Yes, you have many of those situations that you have to face. Two of them, let us do them one by one. One of them is that you have a binomial, meaning that you have an algebraic expression consisting of the sum of two terms, and in many situations you want to raise it to power 2. Okay, so that I'm just trying to tell you that if I write this is an algebraic identity, but this is not something that I really care or I will remember it, because probably it's not that useful. It is just a coincidence that something like this happens and then you have to calculate it. But many times in algebra, even in geometry, in any other parts of mathematics, you have the sum of two terms and you want to square it. In those cases, it's actually important to know to do it once for all and try to remember the rule and use it whenever necessary without having to go through it from scratch. Yeah, so that is the purpose. And in your book, there are only two identities. Of course, I don't know, some of you might have been following my lectures on high school algebra. I have given a lot of algebraic identities there, but at the level of Math 2C, or actually Swedish curriculum, these are the only ones that we want to discuss official. And that is one of them, and that is called squaring rule. Squaring rule. When a squaring rule means that I have the sum of two terms and I want to square the sum. So one mistake is usually people take it as a squared plus b squared. First of all, I want you to know that this is wrong. And I really want you to write it and cross it over unless you have a very nice memory for not doing this mistake. A plus b squared is not equal to a squared plus b squared. So, for example, to rule out this, you can see that, for example, let me choose a to be 2, b to be 3. If I calculate the left-hand side here, this becomes 2 plus 3 squared, then it becomes 5 squared, which is 25. But if I calculate this one, 2 to power 2 plus 3 to power 2, it's 4 plus 9, and it is 13. And you can see that immediately that these two numbers are not the same. So, I don't know, for any way that you like it, remember that in general, this is not true. Of course, I can cook up examples that in which this is true. For example, can you give me an example of an A and B so that the left-hand side becomes equal to the right-hand side?
1.
Yes. A1, B0, yes? For example, if I choose A equals to 1, B equals to 0, then I hope that you agree with me. If I calculate the left-hand side, it becomes 1 plus 0 squared, which is 1, and this becomes 1 squared plus 0 squared, which is again 1. But this is just a coincidence that this works for this special case. This is not something that I can rely on for any values of A and B, for all values of A and B. Yes? Okay, so what is the correct one? The correct one is not only A squared plus B squared, this is 2 times A times B. And I really want you to remember this pattern, even though until the end you will get this formula in the formula sheet. Okay, but I really want you to remember that and try to read it in Swedish or in English or any language that you want. This tells you that if I have a binomial, means I have the sum of two terms, I want to square it, this becomes equal to the first one squared, but 2 times the first one times the second one. If you want, I can put the dots here representing the times. 2 times A times B, and then plus the second one squared. The first thing I want to prove this for you, of course the proof is so simple that you can also do it yourself, but I really recommend you to just memorize it right now. So, if I want to prove this algebraic identity, I start from the left-hand side and try to manipulate it algebraically so that I can go from the left-hand side to the right-hand side. So what can I do? A plus B squared. Any number squared means that number multiplied by itself. Yes? And then I think everything becomes clear for you now. I multiply A by A, it becomes A squared. I multiply A by B, it becomes AB. And then I multiply B by A, it becomes BA. And finally B by B is B squared. But then you immediately realize these two terms are similar. So this becomes A squared plus 2AB plus B squared. And that's exactly equal to the right answer. So of course the proof is actually very, very obvious and simple. But that is an extremely simple but full of application formula in algebra. Yes? Is that clear? So this is important. When do we use this formula? Whenever I have an expression that can be viewed as the sum of two terms. For example, and then I want to square it. If I'm facing such a situation, then it means that I have to have it in my memory. If you don't have it in your memory, of course you have to do it over and over again. I really want you to do it using the formula. And sometimes in the exam, I explicitly mention you use the rule to answer. So it means that if you start multiplying, even though the answer is correct, you will get 0 points for that. Yes? So, whenever you can view that expression as the sum of two terms, and then you want to square it, you need to remind yourself about this squaring rule. Okay, so let me give you a very, very simple numerical example. So what happens if I want to write this? 5x plus 3y squared. Is this rule useful for this? Yes. Why? Because this expression can be viewed as the sum of two terms, and I am interested in squaring the whole package. So this is a squaring rule. Yes? So how should you read it? I want to do the details, but I really want you to just do it quickly. Which one is the first one? Read it in your head. The first one is called 5x. So this tells me the first one squared. So in principle, I have to write it in this way. This is my first one. But plus 2 times the first one, which is 5x, times the second one, which is 3y, plus the second one squared, yes? But you have to continue until you do not have any pairs of brackets left. That is the meaning of expansion. Okay, so what is the answer to 5x squared? This is not a squaring rule, is it? Because that's a product of two terms and you want to square it. And there is no rule, there is a rule for that, but you are already familiar with that. What is the rule? If I have a dot, a product to any power, including power 2, I can write it as an times bn. Be careful. But let me emphasize again. If I have this, do not write that, because in general, this is not true. So I don't have any problems with that one, because this is this old rule. So this becomes the first one squared, 25, multiplied by second one squared, x squared. And then 2 times 5 times 3, it becomes 30. And then I have x times y. And then finally the same thing here, it becomes plus 9y squared. And I really want you, after a little bit of practice, do not write this middle step. Immediately write this one, okay? But if you make mistakes, please do not do that. Write the middle one and then simplify it to this one. So that is the whole point of this lesson. Any questions? Okay, so we have to practice a little bit. First of all, before going any further, is it useful? I'm always talking about the sum of two terms squared. What is happening about the difference of two terms squared? About the product of two terms squared, I do not have any problems. Yes? About the division of two numbers squared, I do not have any problems, because for any n, not just 2, this will work. So this is why we usually do not talk about the product and the quotient, because we already know the rules. What becomes interesting if I have addition between these two terms, and of course what happens if I have the subtraction of two terms. Can I somehow use this? There are two ways to look at the problem. Either you can completely start from scratch, or you can use this in a nicer way. I prefer the second method, but I will tell you this, both of them. So the point is that if I want to write something similar to this, but for the difference rather than the sum, what will happen in the future, do you think, if I calculate everything? Yes, boy?
It takes time.
What then?
It takes time to do everything all over.
Yeah. I mean that what happens at the end? What is the answer at the end? What is your guess?
A squared minus 2ab plus b2.
Plus b squared, yes, exactly. So the answer will be a squared minus 2 times the first one times the second one plus b squared again. First of all, if you don't believe, let us start from scratch. And as Buel mentioned, this is the reason that we really use identities, because if you want to do something which happens a lot, it's ubiquitous in mathematics, every time from scratch it takes time, yes? Why we should waste the time? So this becomes a minus b squared. It is a minus b times a minus b, and then if I do the calculation, this becomes a times a squared. A times negative b minus ab, minus b times a, it's minus ba, but minus b times minus b turns it positive b squared. And then minus ab minus ba is minus 2ab, and I am done. Okay? So that is equal to the right hand side. But there is another way. I myself prefer this one. Of course, for these simple questions, there is no big deal how do you want to look at the problem, but if the problem becomes a little bit more advanced, I want you to learn that. Can I use exactly this identity and find a formula for that? Of course, the answer will be this, but I want to look at this problem in a different way. Can I use the addition somehow to find the formula for subtraction? And this is a standard trick. I want you to immediately answer that. Yes, Buer?
Minus b plus a squared.
Minus b. Yes, that is one way. Exactly. That is not, I was not thinking in that way, but that is also possible, because what she is saying is that minus b plus a is another name for a minus b. Okay, in that case, what I have in between is addition, but what is the first one in this form of writing is minus b. What is the second one is a. Or in other words, let me write it in this way. A minus b can be viewed as a plus negative b and then a square. First of all, I want to make sure that you understand that this equality is valid. Is it? Yes or no? Because a minus b has another name. Of course, this name is simpler than that name. But there is a reason that I am making things complicated. Why? Because now if I ask you in this setup, I have the sum of two terms, you will agree. And then if I ask you what is the name of the first one, you call it A. What is the name of the second one, you call it negative B. And then if you have remembered this formula has a soul to it, yes? It's just not a rigid formula, it is talking to you. If you have two terms, the sum of two terms is squared, square the first one, plus 2 times the first one times the second one, plus the second one is squared. This pattern repeated so many times that you memorize it. So this becomes the first one squared, plus 2 times the first one, times the second one. But the second one is negative b. Plus the second one, negative b, is squared. I continue. So this becomes a squared. 2 times a times negative b becomes negative 2ab. But negative b totally squared becomes positive b squared. I prefer to do it in that way. So in that way, I think in the formula sheet, both of them are given to you. I don't remember exactly. One formula is given with the positive sign. One formula is given with a negative sign. But you can find the other one from the first one. You really don't need to have two formulas. And then one more thing, don't push this analogy further. For example, don't try to write a formula for this. I don't know, might be you guess, I don't know, might be this is your impression that this 1 to power 3, somehow using this analogy, might be you might guess, I don't know, something like this, or whatever you want to guess. These guesses might be completely wrong unless you have a good reason what is the correct formula. So at least this is not the correct formula. If you want to see what the correct formula is, we can discover, okay? But before that, let me just try to write this somewhere and then try to solve some problems regarding that, okay? Okay, so let me write this example now formally. Use the squaring rule So you see, I emphasize here to expand each item. And simplify as much as possible. I always say simplify automatically means as much as possible. So let me write this in brackets. So number 1. So we already did that one. So we can write 2 over 3 x plus 1 squared. Okay, we want to use squaring. If you see this in the exam and you just write it 2 times and multiply them, even if your answer is correct, you will get 0 points for that question. Okay, and even my recommendation is that even if you don't see this in the exam, still you should prefer using the squaring pattern. Try to work with it so that you can get used to it. Okay, Now, let me repeat this sentence at least once more. Is a squaring rule useful here? Yes, because I have two terms. One of them is called 2/3 of x. The other one is called 1. I am adding them and I want to square the result. Whenever this happens, it means that this is useful. So then what should I do? According to the rule that I told you, read it in Swedish or English or whatever, this becomes the first one squared. The first one is this. 2 times the first one times the second one, and then plus the second one squared. Today's lesson is finished. Okay, up to here. After that is just the lesson that you already know. So this means that I square it. This is a number multiplied. This is a number, this is an expression added to something, but that's multiplication. This one squared is 4 over 9x squared. 2 times 2 over 3 is 4 over 3x times 1 is 4 over 3x. And then 1 squared is 1. And then look, is there any way to simplify it further? No, so that's the end of the problem. In the exam, if you go directly to here, I like it more. Even though if you make it quickly and make mistakes, don't do that. Any questions? Okay, and now let me ask you something. What do you think will happen for this? I give you, let me write minus a minus b squared. Can I use that one or no? Minus a minus b squared. So first, guess what is the answers. If you are ready to give me the answer, just read it. If I have minus a minus b, yes, Ali?
It's the same answer as that other rule. In practice, a minus b.
You mean the answer is a squared?
No, it's not the same. Now I think about it.
Okay. Simon?
Plus.
A squared plus 2ab plus b squared.
Yes, it returns back to the first one actually. Why is that? Because if you want to really dissect the problem, this is like this. You need to write minus a. Instead of this minus b, you can imagine plus minus b squared. First of all, I hope that you agree with me. What I have written here is another name for this one. But now what is happening? I have two terms and I am adding them, then I want to square the sum. Whenever this is needed, squaring rule is definitely useful. But you need to remember what to do. You need to write the first one, read the first one, minus a, squared, plus 2 times the first one, which is minus a, times the second one, which is minus b. And then plus the second one squared. So this becomes a squared, and then this becomes 2ab, because minus a times minus e becomes positive ab. And minus b squared is b squared. So as Simon predicted, the answer returns back to the original formula. Another way to look at it. Can you tell me another way to look at the same problem? Could you expect, of course Simon expected, I don't know, how did you calculate this fastly in your head, or you did it in a different way? Because there is also another alternative that I don't need to go through this process, I can immediately understand that, yes?
Well, I knew that it was going to be a squared plus b squared somehow. And I knew that from the previous example that a minus b becomes negative to a. So if I just add another negative, it will become a positive.
Okay, so you were still thinking along these lines. But let me write it with a different color. Another way is to do this is nothing actually using this. One way to look at the problem is minus a minus b squared can be viewed in this way. First, I want you to digest this, yes? Agree with me or not?
Yes.
Because if I multiply this minus sign, minus 1 inside, it becomes minus a minus b. So what I have written here is completely valid. But now, this is a number multiplied by another number, and I want to square it. So this becomes the first one squared multiplied by the second one squared. Don't get confused with the rules. if I have two numbers multiplied and I want to square it, I can square it separately. So that is this one from here to here, I am using this rule. But minus 1 to power 2 is 1, so this becomes a plus b squared. So I realize, without doing this expansion at all, I realize whatever this is equal to that one. And we already know the answer to this. So that is also one way to think about the problem. Any questions here? No? Okay. So there are two natural questions coming in. One natural question is that, what happens if I have more than two terms added? Does it really become useless? I would say no. For example, let me consider this one. If I want to add a plus b plus c and then square it. Yes? So first of all, I want you to understand that is not exactly this problem, because here I have the sum of three terms squared. This squaring rule in its original form only works if I have the sum of two terms and I want to square it. So what is your take on here? What should I do here? Do you think that this is... Of course, one way that you can always use is to write this once more next to itself and multiply it, and after that simplify it. That is always working, but the whole point of the algebraic identities is try to avoid this way as much as we can. Okay, so instead of doing that way, is there any other way that I can use this rule to actually expand that one? Yes?
Should I answer? I mean, you think about them as two terms. You think a
yes,
b plus c.
exactly. So the sum of three terms can be viewed as the sum of two expressions. Yes. For example, let me change my color. What I write in blue is actually my solution. So this becomes equal. I can view this as the sum of a with the whole package of b plus c, and then square it. Yes? I hope that you agree there is no difference whatsoever here and there. What is the benefit of writing it like that? Because in mathematics, usually we want to get rid of pairs of brackets. Here I am bringing in an extra one. There should be a reason that I am doing this. There is a reason, yes? Now if I ask you, can you view this as the sum of two expressions? You would say yes. One expression is named a, the other expression is named pair of brackets b plus c. So that is the sum of two terms. And now remember that English phrase. I have the sum of two expressions squared. According to the rule, it becomes the first one squared plus 2 times the first one, 2 times the first one, times the second one. But the second one is b plus c. And then plus the second one squared. Yes? Is that understandable for everyone? Yes? Okay. Now, still I have to continue because I have pairs of brackets left. Here I cannot do anything. Here I cannot do anything unless I just simply multiply. But here I can use the same rule once more, because I have the sum of two terms squared. Yes? So what happens, this becomes a squared. I multiply this 2a inside, it becomes plus 2ab and plus 2ac. And then this is finished. Now I go here. The sum of two terms is squared. The first one is squared. Remember the phrase, English phrase, 2 times the first one times the second one, and then the second one is squared. Before stopping, you have to make sure that there are no similar terms in this expression. There are no similar terms, you can stop here. That's the answer. Yes? Of course, that is also a famous identity. For example, I have it in my memory, but you really don't need it. Okay, so you just need to know this one. And of course, in the formula sheet you will get it, but I really, really recommend you to memorize that right now. Any questions here? So you see that even if I have more than 2 terms, still I can use the fact. I can use the rule. But if I go, another natural question is that what happens if I go to higher powers? Then this becomes more complicated, and then you will study that a little bit in Math 5. Okay, if you go higher and higher. But of course, if I ask you, can you calculate this one? It doesn't mean that you say no. Okay, how can you calculate a plus b to the power of 3? This is not this rule. This is power 2, this is power 3. What can I do here? Both done. So you are distracting me, okay? You are distracting me so much. You are talking so much together. Okay? If you want to listen to something else, you don't need to be in the lesson. Okay, a plus b to the power of 3. Yeah, we want to do that. What should we do here? One way is to write this 3 times and multiply it, but I want you to learn to use identities as much as possible. So what can I do here? Instead of writing it 3 times, what do I write? Yes?
A plus b squared
Times a plus b. You might say, what is the difference? Is there any real difference? I would say no, but practically yes. Because if I write it in this way, first of all, this is correct. Secondly, I can use this identity for the first part. Yes, that is the whole point of the lesson. So this becomes a squared plus 2ab plus b squared, and then a plus b. And then you multiply. So this becomes a cubed plus a squared. So there is no way, there is no identity that I have it in my memory. If I want to do it, I have to do it. Multiplication. So this becomes a cubed plus a squared b plus 2ab times a becomes 2a squared b, and then plus 2ab times b, which is 2ab squared. And then I come here, b squared a, and then finally b squared by b becomes b cubed. Do not stop here, because we see that I have this one and that one similar. I have these two similar as well. So the answer becomes a cubed plus this one and that one becomes 3a squared b, and then plus 3ab squared and b cubed. Of course, this is one of the formulas that I also have it in my memory, but you really don't need to have it. So the question is that how can I raise it to power 4 and power 5? You can do the questions like that, but later. That is, so in principle, you can answer this question when you reach to Math 5. If I want to raise it to any power n, is there any formula? Yes, there is a very long formula called Newton's binomial theorem. But anyway, this, if I give you this, I expect you to do it in that way, not writing it 3 times, multiplying. Of course, this will give you the correct answer. But what I prefer, and I recommend you to do that, is try to use these identities as much as possible. Any questions? By the way, identities could be fun. For example, if I ask you, what is 605 to power 2? Of course, one way is to put it in the calculator and do it, but can I use a squaring rule to do this? Simpler. Yes, Oscar?
Well, you could write like 600 plus 5.
Yeah, of course I can write it in a lot of ways, yes. I can write it as 599 plus 6 to power 2, yes. This doesn't mean this is wrong, but it is practically harder than the original problem, yes. Because then I have to write the first one squared. 599 squared, I hope that you agree with me, is harder to calculate than 605 squared. So if I write it in that way, even though technically it is right, but this is not efficient. But as Oscar mentioned, I think you agree with him that it is the best choice is to imagine it in this way. Yes? And then what happens? According to the squaring rule, the first one, I have the sum of 2 terms squared. So this becomes the first one squared. Let me be patient and write it once. 2 times the first one times the second one and plus the second one squared. Now I hope that you agree. Calculating each one of them individually is not hard at all. So what is 600 to power 2? 6 times 6 is 36 with 4 zeros. Yes? And then 2 times 5, 10 times this is 6,000. Yes? And then I have 25. So if I add them, it becomes 25, and then I have 0, 6, and then it becomes 3, 6. Yes? So we were able to calculate 605 to the power 2, more or less without any effort. Yes? Is that clear? So somehow you can use these tricks to even calculate numbers. But the point is, I want you to learn, whenever in algebra you have the sum of two terms squared, always remind yourself of that squaring rule. Is that okay? Understandable? Okay. And I think it would be good if I stop here so that you can practice now, because these are important. But there is one more identity left, and that is called the conjugate rule. So squaring rule and the conjugate rule are the only ones that you study in Swedish curriculum officially. But I really recommend you, I don't know, not in the school YouTube channel, on my own YouTube channel, you can find the link on the YouTube channel. There is one playlist called Advanced High School Algebra. And I start with algebraic identities. If you are interested to know a little bit more, I really recommend you to at least to look at the first 2 or 3 lectures, so that you can go a little bit beyond this curriculum. Any questions? Is that understandable? So let us just finalize. If I ask you, I want you to answer. Okay. So what is today's lesson? We want to find famous algebraic identities. Why, for example, even though this one is algebraic identity, this one is algebraic identity, why I don't care about to remember this? It's because this is happening a lot of places in mathematics, according to the experience. So people have formulated once for all to remember and use. That is the goal. When it is useful, when you can have the sum of two terms, either you have exactly two terms involved, or even if you have more terms involved, you can view it as the sum of two terms. Whenever this is happening and you want to square it, this you need to remind yourself about this formula and remember this English phrase. This tells you the first one squared, 2 times the first one times the second one, plus the second one squared. So that is the soul of today's lesson. But you have to practice. You have to practice to do these things quickly, without that much effort. Okay? Yeah. So you can have a little bit of rest until I upload. So what is the question? Yes, Firia, if you want to look at your questions, your exam, you can see it on Wednesday. Yes, yes. Sorry, because sometimes I don't see what you write on the chat window. I accidentally saw it. Okay, so I will update the Google Classroom, and then you know on which pages you have to work. But please do not waste the time, and just go directly and finish this part today. Okay? We will continue to the next one tomorrow. Thank you very much. Have 5 minutes rest and come back.